This brief video will help explain the process of putting together a scientific presentation for your group projects. So you're in the process of developing a research question and a hypothesis, and you're going to create some methodology that will test that hypothesis, and then you'll actually do the experiment, collect some results, and then formulate some conclusions from that. That's basically what's going on in this project. The major mark for it, though, is your actual presentation, which will be done in a group. And sometimes it just helps to have a bit of a guide so that you don't go down the wrong path and make something that's unmanageable and hard to grade. So a scientific presentation is something you may have to do multiple times in your life. If you ever are looking to go into graduate school, obviously it's a staple of something you'll do regularly. It feeds into all kinds of different business environments. So you may have to give a brief presentation in order to move forward on a project or to gain funding for a project, to get ideas from others around you as to how to make something better. Sometimes you'll use a presentation to at a conference, an international conference, present your information to the world or the national meeting, those sorts of things. And you may also use it to graduate with a master's or PhD. So you'll have to do a presentation like this just to graduate. In this course, we're going to do it just to get a grade in the class. And so that's why we're having this discussion right now. So if you're looking at a 15-minute scientific presentation, here's a general template you can follow, and you probably don't want to stray off this too much. The natural impulse will be to create an unmanageable slide deck of 20 or 30 slides long. You can't fit that in. Basically, you're looking at a slide every 2 minutes, minute and a half is what you're looking at when you're doing these kinds of presentations. So somewhere between 8 to 10 slides is usually what you can fit in a 15-minute period. So if you're creating it, first slide is obviously the title, and then you're going to usually need 2 slides to kind of introduce and set up your research question, and then you're going to want a strong slide that clearly states what your purpose and hypothesis is for your study. Then your methodology, sometimes it might take 3 or 4 slides, but you can't dwell on it too long. But generally you can fit it into 2 slides if it's a simple project. The first slide just outlining kind of the subjects you're using and the basic protocols. And then the second slide is more about what specific measures you're going to do and maybe a bit on how you're going to analyze the data. Then you're going to have your results slides, the simple projects you'll be doing. A lot of you will be able to present your results in a single figure. So that could be just a single slide, but some of you may have multiple slides for that. And then usually you'll take 2 slides as a conclusion, one to kind of indicate whether or not your hypothesis is supported and relate your findings to previous research. But then you have to go into things like what are the limitations of your study? What were the weaknesses and strengths of your study? And then usually you finish up by talking about future directions and future research questions. So generally you can pack it into 10 slides. Again, if you go longer than that, you just got to be real careful that you don't go over time. So when you're going through the process of creating your presentation, start with just that rough layout. So basically what I just described here, create your deck right now. If you know your idea, get 10 slides, put a title on one and put an intro at the header on one. So just label your slides. You can easily put the word methods at the top. And so those become placeholders so that when your ideas pop into your brain, you can quickly put them on the appropriate slide and organize your thoughts. Then once you get your slides set up, probably don't want more than 5 or 6 text lines per slide. Do not write in paragraph form. It takes too long to read and it's usually becomes across as crowded unless it's like a quote or something like that. And then make sure that whenever you create a text line, don't monologue too long in that line. So make it every word count. Every sentence has to count for something. Don't use too much flowery language, for lack of a better term. Make sure that the colors don't clash. Some people try and get too creative and they'll put orange on red background or something like that. That's not going to work. It's hard to see. If people are colorblind, then they can't see it at all. depending on the brightness of the room. If the room's bright, you might not be able to see the lettering if they're that close on the color wheel. So make sure it's very clean, not too exotic, and keep it professional. And then whenever possible, try and include some figures to tell the story. Don't just put in, what do you call them? I guess emojis or clip art, just like exclamation marks and things like that, just to be catchy. No, make sure the figures tell your story or relate to your story, or there's some anecdote you can put the figure to what you're explaining in that actual slide. Then overall, the best thing if you want to really nail the marks is to have several eyes on it, get lots of editors, no spelling mistakes. One spelling mistake and you start losing marks, no grammar mistakes. Make sure things aren't cut off like on my slide 3 there. And then you got to practice, practice, practice. So a lot of us think, oh yeah, I'll be fine. I understand the slides. And then you get in front of your group and you start presenting and that sweat hits you and you start to blush and you start to forget all the things you're going to say. So the thing that helps you get through that nerves and anxiety is to practice about 100 times. And then you get really good at doing the presentation. So that's very brief tips, pretty easy, isn't it? So here's a sample of the actual type of presentation you could put together. So here's your title slide, clearly states the title, states your participating group members. Put in your departments. Some of you are department biology, others are other departments, so put in all your departments. And then in this title slide, this is where you kind of introduce your topic. And usually you'll make a statement as to why you chose this topic. Maybe it relates to something of interest in your life. Then here's your first intro slide. Usually your first intro is just general background on your topic. So this study is on the effects of warm up on vertical jump. And so you're going to introduce the concept of warming up. So here's a little bit of research brought in, talking about some studies that show warm-ups improve vertical jump, but other studies show that certain warm-ups won't. It looks like those warm-ups that are more dynamic in nature, so moving through large ranges of motion rapidly, warming the body effectively are probably better than just stretching. So because there's conflicting information, though, this sets up the research question, why are some warm-ups better than others and what is the best warm-up? Can you just stretch like this person down here and expect your vertical jump to go up? Or is a foam rolling a good approach? Or should you do skip rope if you're about to do jumping or some kind of sprinting activity? And so you see this slide helps set up the whole idea behind why you're doing your study. You may want to go into a little bit of background. So in this case, jumping is very important in many sports, basketball, volleyball. Jumping is a form of power. So you want to improve your jump if you're an athlete, that kind of thing. So that's how you set up that general background. Then your second intro slide is usually setting up your specific topic and your research question. So in this case, it's looking at effects of stair running on vertical jump. So what is stair running? Basically, you're running upstairs. There you go. And it involves a lot of muscle, a lot of metabolic output, and you can do it lots of different places. Stair heights are pretty much standardized, so it's kind of the same stimulus no matter where you go. And so the question is, could you just do a stair running warm up, and would that improve your vertical jump performance instead of doing some of these other things? So then that sets up your research question, make an actual question. Can stair running warm up increase vertical jump? Often people state this as a purpose statement, and it's not uncommon, but we've asked for a question and we're grading you for a question, so you better put a question there. And then the hypothesis is basically what are you predicting will happen? So it's being predicted that stair running will improve kind of movement vertical jump. Now you go into methodology, usually 2 slides, might take 3 in some cases. Usually in methods, it's good to start with your subjects, how many subjects, what kind of background, health conditions, those sorts of things. And then usually on that first slide, it's a good time to kind of make a statement of the type of study you're doing. Now, not all of you have had research methods courses, so you may not fully understand specifically what you're doing, and that's fine. But in this case, it's a crossover study. Some of you will be doing a randomized control study. Some of you will do a correlational analysis. So try and fit that in if you can. And then here I show that I'm going to do a crossover study, and then I kind of describe what's going to happen on the different days. And here I'm showing how I'm going to deal with the learning effect and practice effect by doing this crossover type pattern. so that everybody gets the same stimuli but in a different order so that there's no practice effect of learning how to do a vertical jump better. And then your second slide is more usually related to your dependent variables. So what are you going to measure? Well, in this case, the independent variable is actually stair running protocol or control, doing nothing. And the dependent variable is the actual vertical jump protocol. And this is the technique that's going to be used. It's a very simple technique. Doesn't require a lot of equipment, but not that accurate. All right, so once you've set up your methodology, you can show your results. In this case, the study is very simple, comparing a control versus a stair warm-up group. And after collecting the data from your 8 subjects, you got a mean and a standard error. And that's shown here in this graph where your axes are very clearly labeled, units, error bars, and then you can see that difference. And then there's some kind of summary statement saying this is what you're seeing in this figure is a 4% increase in the stair warm-up versus control. So like I said, only one figure here. You may have 2 or 3, so you might need more slides. So then this leads to your conclusions. So the main thing in your conclusions, start by making a hypothesis supported or refuted statement. So did it meet your expectation? And then usually it gives you a chance to go into, does your research match previous research or does it conflict with previous research? Some research may have shown that stair running doesn't improve vertical jump and yours does. So why would yours show that versus that other stuff? Now is a good time to go into limitations of your study. Most of your studies are going to be pretty simplistic, so you'll have lots of limitations, small sample size, type of population used, type of equipment you have available. So if you're doing an ECG and you're using our iWork systems, they're not super accurately placed leads in this case, and so some of the analysis may be limited. Anyway, those sorts of things. So it's your chance to talk about your limitations. Here the figure is showing this is the gold standard. This is what we should have done as compared to this rudimentary chalk on the wall vertical jump technique. Then your second conclusion slides, you could go more into limitations here too, but in this case, this is more about future directions. So basically, you look at your limitations, what you didn't do well, and in your future directions, you basically propose to do the study in the future with more rigor and maybe manipulate some more variables. So there's lots of different variables you can manipulate in the case of this study. And then usually you want to finish with some kind of take-home message or practical application. From your study, is there any information someone could use to help improve their understanding of a certain topic or application in their daily life? There we go, folks. So there's your outline for your scientific presentation. If you follow this model, pretty good start, and then practice, 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 and you should be golden. Thank you for joining me.